Welcome everybody to this session on real-world data science. As usual, if you want to know a bit more about myself, please visit this particular video. And this is the video. If you, what I recommend to understand some basic technical stuff, please look at 2 videos. About which I'm going to talk about, please look at these 2 videos. Okay. So the data science, real world data science course, we have 3 major parts. Okay, mathematics and programming part, business angle to data science, which is what we are currently doing, and functional alignment. So this is a circular course, which means there are 20 sessions and we keep doing. After the 20th session, we'll begin the first session. And I just wanted to show the curriculum. So first 8 sessions are technology driven. So we showed a lot of programming use cases. If you joined in the last class, don't worry about it. And if you joined here, we will go through this and you will learn the programming at the end towards the last part. So this keeps circling around. Currently we are in session 12. And for understanding session 12, you have to go through the lectures 9, 10, and 11. So if you join today and you are listening, I think you should be able to understand most of it today. But what I recommend is just review these 3 videos in the L, so you will understand the content a lot more clearly. All right. So that's, and then after this, we'll have a functional alignment. So there are a few classes on the functional side, right? So this is the last class in the series of design thinking. Next class, we will go to data-oriented things, business module, but data-oriented. So today, I want to, not right now, in the middle of the class, the poll, please, please do it later in the LMS or something. Thank you. Okay. So see, whenever you are building a data science based model, one thing that you want to understand is how good is that model. It may look funny, but many people don't understand this right. There are 2 types of biases. The one of the things is they will say, I want 100% accuracy. Why should you 100% accuracy? When you are building a model to replace a human guess, to replace another model, isn't it enough if the new model is 5% better than the existing guess? Isn't it better if it is if it gives you $1 million more than the existing model? It should be. But most of the times when we want to design a data science model, our biggest complaint is, you know what, it is not giving me 100% accuracy. Or if you want to be reasonable, 98% accuracy. The question is, how am I doing it currently? If currently I am doing it at 53% accuracy, maybe 56% accuracy is good enough, right? So that is the first part. But the second bias is, even though many people think about the accuracy correctly. And by the way, I work with as a consultant for one of the large consulting firms. This is like top 4 consulting firms. Once that guy calls me, my partner, and he says, Murthy, please tell me, how do I get out of this consulting work? One particular consulting project. I hate to be in this project. I want to get out. How much ever accuracy I give, the client still wants to do one more exercise, improve the accuracy a bit more and a bit more and a bit more. Okay, so tell me how to do. And I told him, you should have talked about how much you can give upfront. Many people don't do it. Okay, let's say people do understand this, how much of accuracy or how much of statistical improvement we need. They compared with what they have already and they can come back. But that is only one of the many components that measure the performance of a data science solution. So whenever someone gives you a data science problem, you should ask them, hey, when I build a model, what is the performance you need from statistical, business, and engineering side? And I will explain it with a story. Today, there are going to be many use cases. Some of them I participated. Some of them are so popular in the internet, so I will repeat them. But let me explain having a measurable performance metric, well thought out performance metric, how important it is. Now, thanks to pandemic, I'm sure all of you are extremely familiar with Netflix. Okay. In 2004, 2005, when Netflix started, it started as a video rental agency. Actually, in 2000, when it started as a video rental agency. So it is not a video streaming company, video rental agency. So people actually go on the online, look at the video cassettes, and they take one cassette, and then Netflix sends them by post, and they will read it, they will watch it, and then they send back. Now, a recommendation engine is very important for Netflix. So when people go there, click on one video, if they can show a relevant video to them, and if they order, number one, 2 videos, postal charge will come down for the individual, and for these guys, top line just goes up, right? So it's very important for Netflix to recommend properly, and they built a recommendation engine. Suddenly in 2006, they came up with an announcement which shook the internet. They said, look, I have a recommendation engine. If you can beat my recommendation engine by more than 10% accuracy, I will give you $1 million. I don't know how many of you know this joke or not. There is a joke about mathematicians. What is the difference between a mathematician and pizza? Okay. A large pizza can feed a family of 4, and a mathematician cannot. That's the joke. Not anymore, but 15 years back, that was the kind of life mathematicians are having. Now imagine a company comes and says, if you can develop a better mathematics, give me 10% more accuracy, I'll give you $1 million. The mathematics community was shaken, and 2,300 teams, some of the brightest and smartest minds in the world, started competing. Netflix gave a lot of their customer data, which got into a legal hassle later, but that's not the scope of what I wanted to talk about. So to give due credit, within 3 months, a mathematician came up with a model that gave 8% more accuracy than what Netflix had. But Netflix was vehement, adamant. It said, no, I said 10% or more. Why do I don't care 8%? Get me 10%. And it's like these running races, you know, in Olympics, getting 9.6, 9.7, 9.9 is okay. It is tough. But after that, every 0.01 second improvement will require enormous amount of practice. Right. So these guys fought and fought. By December 20th of 2006, they went back to Netflix and said, boss, we are at 8.9, man, accept it. Netflix said, nothing doing. I want 10 and go give me 10. Okay. And then Netflix said, okay, take Christmas break, take New Year break, come back on 5th January, let's fight it out. And 2007, again, whole year they fought. December 20th, contestants are tired and worn out. They said, hey, we are at 9.5, buddy, better than you. Please accept. Netflix said, nothing doing. Fight it out. Take Christmas break, New Year break, come back. This is 3rd year, right? 3rd year, sometime in June, July, one guy said, finally, hey, I have 10.04% more accurate than Netflix. Within an hour, one more guy posted, I have 10.05. See, data science at some level is a curve fitting job, right? You give me something, I can tweak it a bit more and a bit more. And they started now improving and improving. 10.061, 10.062. Netflix said, okay, time out. August 15th or August 16th, Eastern Standard Time, evening, 5 p.m., the goalpost is closed. Whoever has the highest accuracy by then is the winner.